in section 3.4, we found the maximum and minimum of functions by setting the derivative equal to 0 so that we could see the slope of the tangent line and where it goes horizontal and has a slope of 0, so that you can see down here we've got a minimum on this function. We're going to do the same thing in 3.5, but in 3.5 we limit our domain of our function. So you can see in this case we've got a short interval between x equals -8 and x equals 5 for that same function. And now we're going to be looking for absolute maximum and minimum values on this little interval. So you can see that we should definitely be checking our endpoints of our interval, but also looking for the critical values for the same reason, because we would, in this case, we would have a low value here at absolute minimum down here. Let's do this problem algebraically. All right, here's the function that we were looking at. The function is f of x, which is 3x squared plus 18x minus 4, and there's the interval -8 to 5. Notice we've got the interval notation with brackets because we're including x equals -8 and x equals 5. All right, so first we're going to find the critical values, and that, if you recall, is where f prime of x is equal to 0 or it's undefined. So the first derivative of the function f is 6x plus 18. Pretty straightforward derivative to find. We need to set that equal to 0 to find the critical values, and that only occurs where x equals -3. So x equals -3 is another contestant for a maximum or minimum. So recall we're going to look at the endpoints, x equals -8 and 5, and now we also get to look at -3. F prime of x is not undefined anywhere, right? Because it's not a rational function, so we don't have any derivative or any denominators equal to 0. So we're cool, that's the only critical point. And so we're just going to have to check the two endpoints and that critical point of x equals -3. Now remember, we're plugging these values, these three contestants, into the original function because we want to know the height of the function at these 3 points to figure out which is the highest point and which is the lowest point. So f of -8 gives us 44, and plugging in -3 to the original function of f gives us -31. And the last one, f of 5, is positive 161. So that seems like that's the highest point. And if you look, you're just looking of those three values, of those three function values, we want the lowest one, and that's definitely going to be our absolute minimum, and the highest one is going to be our absolute maximum. So notice we give our maximum and minimum values as x, y pairs. So the maximum is that 161, and that was given at x equals 5. So 5 comma 161, and the absolute minimum is x is -3 and y is -31. Yay, winner, winner. And if you look back at our function here on beautiful Desmos, you can see that this endpoint of, at -844 was one of the contestants, but it wasn't a max or min. You can see it's sort of in the middle. But this point, as we predicted, -3, -31, is the absolute minimum. And if you go all the way over here to the other endpoint, if I could just drag it, come on friend, come with me. Well, in any case, it's at 5, and I believe it was, oh, there we go, at 161. Cool, and that's the absolute maximum on that interval, which is exactly what we were asked to find. Okay, let's do another example, this time mostly algebraically. We'll find the absolute extrema, that is the maximum and minimum, for f of x is x to the 2/3 power plus 1, and our interval this time is x goes from -8 to +8 inclusive. All right, so first we find the critical values for f of x. F prime of x is 2/3 x to the -1/3. I know you people don't like fractions, but fractions are your friends. All right, you can rewrite this negative exponent by making it a positive exponent in the denominator. And that's helpful in this case because we want to figure out where f prime of x is equal to 0. And you can see that since there's no variable in the numerator, this fraction can never equal 0. Okay, but we can decide that, or we can determine that it's undefined, the function, the f prime of x, the derivative of the function, is undefined where x equals 0, because you can't have a 0 in the denominator. So that's the only critical value, is where x equals 0. So all we have to do is evaluate the function at the three different contestants, right? We have x equals -8, which was the first endpoint, x equals 0, which was that critical value where the derivative equals 0, and x equals 8 is that farthest endpoint. And evaluating them all, we get x equals -8, the leftmost endpoint was the absolute max, and the middle one, that critical value where the derivative is undefined, we got a minimum. So that's the absolute min. And not coincidentally, you'll see why in a second, the other endpoint, x equals 8, was the same height. It's also 5, so it's also an absolute max. They tie. That's nice. It's friendly. It's like in elementary school these days. The largest value. Let's see. Okay, good. We already found that. Okay, so let's see why. It's a super cool function. It's got this very pointy bit down here, and you notice right here where it's super pointy, that's where the derivative is undefined. Okay, since it's pointy. Hopefully you learned that in an earlier section, but yet that's where you're going to have derivatives being undefined, because you can't have a tangent line there, right? So there's no slope of any tangent line. Okay, and you can see also why both of those endpoints are maxima. All right, next example, we're going to do the same thing, but for a new function, 1/3 x cubed minus 9x, and our interval is 0 to 4. We're going to find the critical values of f by finding the derivative. So x squared minus 9 is the derivative. Setting it equal to 0, we get x's plus and minus 3. Something interesting about this one, though, is notice first of all, there's no place where f prime is undefined, so our only critical values are -3 and 3. And so you would say, oh, well, we need to check both endpoints and the critical values, but notice that -3 being one of our critical values is outside of the interval 0, 4. In other words, -3 is less than 0, so it's not in this interval 0, 4, so we don't have to check that one. So I just wanted you all to see that can happen. So got to stay on your toes here. All right, so we're just going to evaluate the function at the two endpoints, 0 and 3, and one of the critical values that's in there, which is, which was the one, what? 3, okay, good. So 0, 3, and 4 are evaluated, and we get that 0 is the max and 3 is the min because they turn out to be 0 and -18 respectively, whereas 4, the other endpoint, was -14.67, so not quite low enough. And you can see here's a graph of the function. They don't show you where the endpoints are, but the endpoints I believe were 0 and 4. So here's where x equals 0, and here's where x equals 4, right here at this point. So you can see why this endpoint of x equals 4 is neither an absolute max or minimum. If they had chosen an endpoint at like 6 or something, then that would have been an absolute max. So that interval definitely plays a role here. So that's basically it. There's not much to 3.5 that we didn't cover already in 3.4. The only difference is now we have endpoints, and now we can call them absolute maximum and minimum points on the intervals. So that's it. Have fun. Homework should be pretty easy.